Welcome back to the classroom. My name is Mr. Wong, and today we're going to be looking at the methods of dilution, and we'll be going through some calculations regarding dilution and how to perform them. So firstly, let's just recap on what is a dilution. The idea is very simple. If you look at the animation that we have here, we are increasing the volume in a solution. So concentration, we mentioned before, is measured in moles per liter. Moles represents the number of atoms or compounds, and liters obviously volume. So as I increase the solvent, in this case water, we are decreasing concentration. When concentration decreases because of an increase in the solvent, this is what we mean by a dilution. So if concentration decreases due to an increase in the solvent, then that's where we get a diluted solution. Okay, so there's that. But what I want you to try and take into account is as the solvent is increasing, the number of particles actually stays the same. If we have a look, so diluting solutions, we can actually compare the two beakers here. One has a 100 milliliter of solution. It has this amount of particles, and we actually increase that volume by 250 milliliters. Okay, you can see the volume has increased. However, the number of moles or the number of particles have remained the same. So what we actually know is when diluting solutions, an increase in volume leads to a decrease in concentration because the number of particles remains the same. If we write out the formula from before, we said that concentration is equal to the number of moles over volume. Now, N is constant. It is not changing. Okay, so we can actually say that concentration is actually inversely proportional to volume. If volume increases, then concentration decreases. If it was the reverse, we'll use a different color. If volume was to decrease, then that means the concentration would increase, and that's where we get a concentrated and potentially a saturated solution. Okay, so that's how they are related. We talked about the methods in, performing a dilution. So we actually need to use one of these instruments known as a pipette. I think I spelled that right. Pipette. Okay. There's a little signage on top where it's a little line that accurately tells you how much of a particular volume you need. Usually the pipettes we use are about 15 to 25 milliliters. Okay, and you would extract a certain amount of your what we call the stock solution, or the standard solution is what we also call it. So we take some of that standard solution and we transfer it into a new volumetric flask. So these two kind of odd shaped flasks, we call them volumetric flasks. And what's actually happening is we are using a certain amount of that liquid. Let's say we put 25 milliliters of that liquid there. So we still have the same number of moles. So the concentration here is still the same as the concentration here at this current point. Okay. However, we are going to then add the solvent into the second volumetric flask, and that will cause the solution to become diluted. We still have the same number of moles, so we have the same number of moles in this solution as with this one. However, because we've diluted it with more solvent, the concentration decreases. The solvent we usually use is distilled water. So that's the idea that we have here. when it comes to performing these calculations, there's a very straightforward formula that we can take into account. So given that the dilution process means we still have the same number of atoms or the same number of moles before and after, we can say the original standard solution, we have N1 amount of moles, and then in our diluted solution, we have N2 amount of moles. So we can say the number of moles will still be equal to each other. Now we know for a fact that the number of moles is equal to concentration multiplied by volume. So if that's the case, I can actually substitute CV into these two components here. We have C1, V1, so that's a concentration of our standard solution or the stock solution. And then C2, V2, that's the concentration and volume of our diluted solution. If I want to try and find what the new concentration of my diluted solution would be, or maybe new concentrated solution, I can rearrange, move V2 over, so divide it on both sides, and I will get this formula here. C2 equals to C1, V1 over V2. So that's what we have. Okay, so let's try and go through some calculation questions and solve for our dilution problems. So we have Louis here. Louis had a 1 mole per liter of sodium chloride. So that's going to be C1 for us. And he made a 500 milliliter of a 0.1 mole solution. So that's C2. Find the volume used by Louis to make this solution. So this is V2 we're looking for. It says V1 here, but that should be V2. So V1 was originally 500 milliliters. We need to firstly make sure, if we just write out the numbers we have, V1 needs to be in liters, so 510 to the power minus 3 liters. And then C2 is 0.11 or 0.100 moles per liter. So that's what we have. So all we really have to do is do a quick rearrangement. Okay. So, oops. All right. So just quick correction. That was actually V2 there. My apologies. So that's V2. So we still have V1. So we want to find V1. What was the original volume we extracted to then make the 0.1 mole per liter solution? That is now 500 milliliters. All I have to do is substitute into the equation. I have a concentration of 0.111 times or multiplied by 500 milliliters. That's converted into liters. And with a concentration of 1.00. I find that my volume 1, I would have extracted 0.0500 liters. Okay, so that's what we have. So in that case, about 50 milliliters to get that particular solution there. Remember, volume is always in liters, so make sure you don't confuse that. Okay, so let's go through some other forms of calculations. We have Nathuli trying to prepare a dilute solution of sulfuric acid from its concentrated form. We want to find the volume required from a 18 mole per liter, that's incredibly high in concentration, that's C1, to make a 5 liter, that's volume 2, to a 2.5 mole concentration of sulfuric acid, that's C2. Okay, so again, ignore the hint one here. If we actually try and do the rearrangement, okay, we want to rearrange to find V1. So V1 would therefore be C2 over V2 over C1. So we find that it's 5 liters. I don't have to do any conversion this time around because it is already in liters, times 2.5 over 18, and I get approximately 0.69 liters. Okay, I rounded off to 2 significant figures because, as you can see in my question or in my calculation, the small significant figures used is 2. So I rounded off to 2. Question 3, we have a 5 milliliter of 4.5 moles battery acid. It is diluted to 100 milliliters. Okay. Calculate the concentration of the diluted battery acid. So again, write out our formula. Okay. And what we can see is we want to find C2. So C2 is C1V1 over V2. That hint that I had up here was probably written for this one down here. Okay, concentration 1 is 4.5, 0. I'll just make sure to write down all the significant figures that was given to me in the question, so I don't forget in my rounding off. And what we also have is volume, so 5, and that is therefore converted into liters. And then we also have 100 milliliters, and that leaves me with an answer of 0.225 mole per liter. If I round it off to, well, actually I have the right rounding off anyways, 3 significant figures, mole per liter, all good. So that's how you do that question there. Okay, let's try one that takes a couple more steps or has a bit more complexity to it. So we have young Daisy here. She made a volume of sucrose, or she has a volume of sucrose from this particular concentration and diluted it to this volume. So that's V1, or V2, sorry. That's V1, and that's our concentration 1 there. Now, the question says to find the concentration of the solution in moles per liter and to also find the concentration in grams per liter. Okay, if we're talking about grams per liter, that's relatively straightforward. Again, we go back to this formula here. We want to find C2. So it is C1 V1 over V2. And what we have is, obviously, if we're doing grams per liter, we need to convert the grams per 100 milliliters into a liter. Now, in 100 milliliters, you need to times it by 10 to get it into 1 liter. So the number 84.1 grams per 100 milliliters. If I times this value by 10, 841 grams per 1,000 milliliters. That is equivalent to grams per liter there. So 841 is what I need to use. I multiply that by the volume, which was originally 25. So 25 10 to the power minus 3 liters. And then we also have the volume we're diluting it to, which is 500 10 to the power minus 3 liters. And we get approximately 42 grams per liter. Okay, so that one there is done pretty smoothly. Hopefully that was straightforward enough for you. The next one we need to find is therefore moles per liter. So firstly, we need to know the number of moles we're dealing with here. So given the fact that we are trying to find it in liters, again, we use the same method. We assume that we're dealing with this as if we had 1 whole liter of this sucrose. So the formula for sucrose is C12H22O11. Okay. The molar mass, or the mass used, sorry, firstly, is 841. The molar mass of sucrose that I found was 342.296. And that gives me this amount of moles of sucrose. Okay. I'm not going to do any conversions or significant figure changes just yet because this is, you know, the number of moles of the product that I need. Next point is I need to find concentration. Now, concentration, following the same formula, we need to find the overall, the overall concentration of what we have. Okay. All right. So with the assumption that this was 841 grams was for 1 liter of our sucrose solution, we can also deduce that the original concentration would have just been the number that we had, the number of moles, this bit that we had just here, divided by 1 liter. So we could also say that this number that we have here was actually the original concentration in moles per liter. So we have 2.4, yada, 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 numbers, like that. We multiply that by the original volume, which is 25 10 to the power minus 3 liters. Just managed to creep in enough space. 500 10 to the power minus 3. And that gives us a molar concentration of 0.1228468.928. If we round that off, the lowest significant figures used in the question is 2. So it's 0.12 moles per liter. Okay, and that's what we have there. You could, in a way, use 42 grams to then work out the number of moles that you have backwards. That also works too, and you should find the same number as well. Okay, so the last example we're going to use today is Max, who uses 16 milligrams of silver nitrate and dissolves it in a 500 milliliter solution. Calculate the molar concentration of the solution made by Max. So in this case, we are looking at the standard solution that Max has made. What we need to do firstly is find the number of moles used, because we don't actually have the number of moles. As you can see, we only have mass, we only have volume. So the number of moles of silver nitrate in this case is 16.8 milligrams. So if it is milligrams, we want to convert that into grams. Okay, so to get it into grams, divided by 1,000, so it's 10 to the power minus 3 divided by the molar mass of silver nitrate. Now I found that it was 169.9, and that gave me exactly 9.89 times 10 to the power negative 5 moles of silver nitrate. Okay. Now what I want to find is the molar concentration. So Ag nitrate, number of moles over volume. The number of moles I have, 9.8 or 9.89, 10 to minus 5, divided by the volume that we have. This is where we put in the 150, 10 to the minus 3, and if we have a look, 3 sig figs seems to be the numbers that we have here. one could argue maybe that the 150 is 2, but let's just say it's 3 in this case. So it's 6.59 times 10 to the power minus 4 moles per liter. So that's how you do that question there. Okay, question B. So using his standard solution, Max wants to reduce the concentration of the solution by 10. However, he has not eaten and needs someone to help him out. So we want to help Max calculate the volume required for this particular request. It could be Max hasn't eaten, he hasn't had his chicken wings, maybe he hasn't, gone to his shared tea, who knows. But what we want to find is volume, so that's volume 2. Okay, so rearrange the equation C1 V1 over C2. C1 in this case we already had was the 6.59. Now that was the rounded number. And so technically speaking, because we're doing a new calculation, we should be using the full number that was calculated for the original concentration. Okay, so the original number I had was 0.00069593333. I think that's enough threes, over like so. Okay, and then the volume we had was originally 150, and the concentration that we now have is 1/10 of this original solution. So if it's 1/10, we just increase the amount of zeros by 1, 1, 2, 3, 4, and we go from there. Okay, just remember, if I want to decrease the concentration by a factor of 10, that means we move the decimal point, in the other direction by 1 position. So, basic mathematics here. Okay, so the final answer we get, we're going to round it off to 3 significant figures. And I find that the amount of solution, or the amount of volume to decrease this by a factor of 10, is 1.50 liters. So I need to use that amount of solution, okay, 150 mils of that solution, take it to 1.5 liters, so add my solvent in this case probably distilled water, to 1.5 liters, and that will decrease the concentration by a factor of 10. Okay, so that concludes the recording to explain how we can dilute a solution and the methods of dilution. Hopefully you found this video useful, and I will see you next time. Take care.